Okay, today we'll see the GPU. Okay, GPU is nothing but the graphic processing units with the which we have the some host code here. Okay, we have the host code. Okay, host code is nothing but the on the host code only we are running the some programs. Okay, which will help to provides the some platform to write up some programs. Okay, which with the help of the host code that's to be related to IO. Input and output. Okay, that code would be what in the standard C programming only. That is to be what in the standard C programming. We can also write the programs like with the C, C++, Python also with the interface of what type CUDA interface. But here with the GPUs, if I use the host code, there I have to use what here the standard C code only. Standard C code only. Okay, even the GPUs also provides the debugging. Okay, if I have the so many the programs, okay, threads, if I running, that is to be automatically debug. Okay, one by one. Okay, and even I will be using the two okay, that's to be what here the standard output and standard error. Okay, if I want to run the if I want to display the something to the user, then I'll be using the std out. If you want to write the write into the okay programming set, that is I'll be using the stdin. If you are getting the any errors, then I'll be using the std error. Okay, std out is helpful for me write the some messages. Okay, to related to display the user. Okay, related to display the user. Okay, I hope it's clear. Okay, is the each thread in the work. Okay, write the std out with the process of the order. Okay, if the number of threads are there, okay, they are not running with the order. Okay, if you want to run the threads in the properly in the order way, then I would use what here the std out. Std out is nothing but this is the one of the keyword we'll be using for the writing the program with the help of the in order to execute the program. So in order to execute the threads in order. Okay, orderly. Okay, one by one another. Okay, and also I'll be using the that is nothing but GPU thread has the access the std out and std error and also secondary storage. Okay, sometimes I'll be using the std out even the secondary storage also. Secondary storage purpose I use the GPU thread to access the std out and std error also. It means here that we will be using the different types of keywords for the std out for display purpose, error purpose, and also in order to get the writing into the back to the program, we will be using the different types of keywords in the GPUs. Okay, this is all about the GPU. Okay, this is all about the GPU. If I go with the performance, okay, if I go with the performance side, okay, performance. Okay, GPU performance, it has to give the some good execution. Okay, good execution, increase in the performance. Okay, the it means here the if you want to execute the some programs, that has there I have to get the good performance. If my programs are running in the faster manner without any disturbance, that's to be what here the increasing of the performance. Okay, to speed up and efficiency in order to get in the MIMD systems, so I'll be using the two techniques, that is nothing but they divide the work into equally. Okay, if I have the work, okay, larger work is there, any larger program is there, that is to be divided into number of small works. Okay, number of small works introducing the some equally. Okay, if I have the 30 threads are there, then the work should be divided into each and every thread with the same amount of work to the particular thread. Okay, ನನ್ನಲ್ಲಿ 30 ಥ್ರೆಡ್ಸ್ ಇದ್ರೆ ಅಲ್ಲಿ ಏನಾದ್ರು ವರ್ಕ್ಲೋಡ್ ಇದ್ರೆ ಆ ವರ್ಕ್ಲೋಡ್ ಅನ್ನು 30 ಥ್ರೆಡ್ಸ್ ಈಕ್ವಲ್ ಆಗಿ ಡಿವೈಡ್ ಕೊಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಏನಂತ ಡೋಂಟ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ದ ಎನಿ ಅಡಿಷನಲ್ ವರ್ಕ್ ಟು ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಥ್ರೆಡ್. ಯಾಕಂದ್ರೆ ಇಫ್ ಐ ಇಂಟ್ರೊಡ್ಯೂಸ್ ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಒನ್ ಮೋರ್ ಅಡಿಷನಲ್ ವರ್ಕ್ ನಾವು ಕೊಟ್ಟರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಆ ಥ್ರೆಡ್ ವಿಲ್ ಟೇಕ್ ದ ಒನ್ ಮೋರ್ ಟೈಮ್ ಟು ಎಕ್ಸಿಕ್ಯೂಟ್ ದಟ್ ಒನ್. Okay, time to execute. Okay, in order to avoid this one, we'll divide the work only equally to the all the threads, or work into the all the threads. But if thread 1 is having the more work compared to the thread 2, thread 3, then it will take the more time. Okay, it will not give the good efficiency, and also speed also it will not get. Okay, in order to get the good speed up and also efficiency, then I have to divide the work into number of pieces. Okay, which is to be related to thread 1, thread 2, thread 3 equally divide ಮಾಡಬೇಕು. If my thread 2 is getting the more work, then that will take the more time to execution and so that it will not give the good speed up, okay, good speed. And also even I will not get able to get the, I won't able to get the good efficiency also, good efficiency also. So that here the, I will be considering here the number of threads here, the what here the p number of threads here, okay, p number of cores, sorry, the here the p, I what I'm using here the p is there, no, if the number of cores are p, ಇಲ್ಲಿ ಕೋರ್ಸ್ ಏನಾದರೂ ಏನೋ ಕೋರ್ಸ್ ಪಿ ಅಂತ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿ, that is to be used to run the threads in the serial or parallel. Okay, if I consider the some threads which is to be run in the serially, then the I have to take the t serial, okay, t serial, that time is to be taken for the running the programs, okay, threads. Now if I take the few more time, that is to be what here the for running of the parallel programs, okay, parallel programs with the different threads with the parallel, then the time taken for the running the threads within the parallel program, that is to be what t parallel, okay, t serial matta t parallel is these are the run times, okay, these are the run times which will be given for the running of the 10 okay threads which are in the serial program. And also t parallel is the runtime which will be taken for the running of the threads in the parallel programming, okay, parallel programming, okay. Then the I have to write here the t parallel in order to get the threads to run the in the parallelly, okay, parallel means it speed, okay, with the speed. Then I have the some formula there here, okay, t parallel equals to t serial by p, t serial by p, p is the what here the p is the number of cores, number of cores andre number of processors, okay, there I am using, okay, in order to get the good performance in the high efficiency and with high speed up, then I will be having the one formula here, the t parallel equals to t serial by p. Here the p is what here the number of cores which I am using for running the serial threads, or else it is to be used for the running the parallel threads. Okay, usually the our programming, okay, CPU will use the serial thread, okay, t serial, okay, but in GPU will use the uh, t parallel, okay, t parallel means what here the parallel, GPU will provides the completely parallel programming, okay, parallel programming, parallel computing, but CPU will not provide the complete parallel programming. So we are studying here, what we are studying, GPU, graphic processing unit, okay, graphic processing unit can have the work here, work used to be divided into equal ಆಗಿ ವರ್ಕ್ ಅನ್ನು ಡಿವೈಡ್ ಮಾಡಬೇಕು. So the each and every workload, okay, each and every work to the particular thread has to be correct, okay, it should be very perfectly. But if it's any excess to the particular thread, will have the more work, then that will the it will not give the good enhancement in the speed up of the execution of the program, so that will not get the good efficiency. In order to get the good efficiency, we should have to give the more, okay, correct work to the each and every thread, and also we should not give the additional work to the particular thread also. And also we have the, in order to convert the serial programming into parallel programming, we have the how it is depends on what here the number of processors. If the number of processors are 10 only, will not get the good parallel programming. If the number of programming processors are more than 10 to 100 to 1000, there will get the good parallel computing. That's nothing but the parallel computing. So that it will take the time to run the particular threads here the in the serial, p serial, and also in order to convert the serial programming to the parallel programming, will take the execution of the particular thread, which takes the t parallel, okay. There is a communication, okay. In order to get the good parallelism in the parallel computing GPU, there I have the one formula, that is the t serial by the p, okay. Here the p is what here the number of cores, number of processor, number of cores anbodu ಅಥವಾ processors, okay. Take the, for example, okay, if I have the whatever you are studying here, the whatever you are doing here, the t is parallel to t serial by p, it will give the linear linear speed up, okay. We will get the good speed up, but here the linear speed up also we are getting here the linear speed up also, okay. We will get the linear speed up. Linear speed up is the what here the linear, okay. As the time increases, number of threads also increases, okay. Then the number of threads will increase, sorry, number of, as the number of processors increases, the execution speed is also increases. execution speed also increases. This means what here the linearity. Okay, speed up is here what here the linear in condition, means what here the both are syncing each other. Okay, in practice we usually don't have get the such a perfect linear speed up in the in practice. Okay, in order to overcome such an we will such a problem, we introduce the one of the overhead. Overhead antandre, if the thread one is having the only particular period of particular work, if the another thread is also having the same work irutte, but if the thread one is having the more than the thread to work, then the thread one will be under what here the overhead. Okay, ಒಂದು ಥ್ರೆಡ್ಗೆ ಎಲ್ಲ ಥ್ರೆಡ್ಗಳಿಗೆ ಸಮಾನವಾಗಿ ಕೆಲಸ ಕೊಟ್ಟಿರಬೇಕು. ಒಂದ್ ವೇಳೆ ಒಂದು ಥ್ರೆಡ್ಗೆ ಏನಾದ್ರು ನಾವು ಜಾಸ್ತಿ ಕೆಲಸ ಕೊಟ್ಟರೆ ಏನಾಗುತ್ತೆ, ಆ ಥ್ರೆಡ್ ಏನಾಗುತ್ತೆ ಅಂಡರ್ ದ ಕಂಡೀಷನ್ ಆಫ್ ವಾಟ್ overhead, over condition ಇರುತ್ತದೆ. Okay, for example, so threads memory programs. Okay, shared memory programs, sorry, shared memory programs almost always have the critical sections. Okay, such a critical section shared memory programming ಅಲ್ಲಿ almost all overhead ಇರುತ್ತೆ because of the critical sections. And also we have the some okay, which will requires the critical exclusion mechanism that we call as the mutex. Okay, mutex is nothing but the we have seen in the last class. Okay, mutex. Okay, which will provide what here the overhead detective. Overhead will not give the mutex. Okay, okay. This is all about the some programming side. And also if you go with the, this is all about the shared memory programs. If I go with the distributed memory programs, almost all always need to transit, okay, data across the network here because of the distributed memory. Here the data is not transiting in the shared memory programming, but here the distributed memory programming side, the data has to be always it has to be always what here the it has to uh, it has to transit from one core to the another core. Okay, okay, because of this one we'll get the slower execution of this one. Okay, slower execution of the slower execution. Okay, in order to get the good speed, we have the to okay formula as the t serial by the t parallel. Okay, to define the speed up of the parallel program, we have the one more formula that is called the to increase the speed up. Okay, to increase that to get the good speed up, we have the t serial by t parallel. T serial by T parallel. Okay, that's nothing but the okay. If you define the speed up of the parallel program, we can define the speed up of the parallel program. Okay, till now you have seen the period of time. Okay, whatever the time you are consuming for the parallel converting the serial program to the parallel program, we will have the T parallel to the T serial by P. Okay, in order to get the good speed up, we have the if we can define the speed of the execution program with the T serial by the T parallel. Okay, T parallel serial is the used for the execution time period for the serial programming, and also T parallel is the converting of the serial program to the parallel program, which is to be done with the T parallel. Okay, T parallel timing in the T parallel programming. Okay, in this such a situation, if you want to get the linearity in the speed up, okay, we have seen the linearity in the execution time, but even the linearity we can see get the in the speed up of also with the help of what here the S equals to P. Okay, S is nothing but the speed, the P is nothing but the number of cores. I mean, what are we using for converting the serial program to what here the parallel programming. Okay, parallel programming. Okay. Okay, furthermore, if you go with the okay efficiency, okay, what else? Speed we have seen, and also time of the converting the serial program to parallel program we have seen, and also speed we have seen. If you go with the efficiency matter, E equals to efficiency is what here the efficiency is what here the S by P, S by P. Efficiency is the S by S is what here the speed, P is the number of cores. Okay, S is what here the S we already seen the T serial by T parallel. T parallel. P is what here the completely P is here. Okay. That's arithmetic EP. Okay, okay. Take the heading as the parallel GPU. GPU ಅಂತ ಬರ್ಕೋರಿ heading. Okay, in most of the cases, okay, efficiency can be teach like it will be taken the fraction of second to run the particular thread or process. Okay, this is what here the efficiency. That efficiency can be defined for the parallelism with the help of what here the e dot t parallel equals to t serial by the p dot t parallel. Okay, as you already knew this one. Okay, t parallel. Okay, the efficiency of the t parallel can be here the t serial by t parallel and t parallel gets cancelled. Okay, we get the t serial by p. Okay, by p. Okay, p can be, okay, we have the efficiency for the t parallel equals to t serial by p. Sometimes they will ask for they will ask the problems also in the question paper. Okay, if you just to find the efficiency for the given parallel program, we can also give the t serial by p itself. Okay, t serial by p. Okay, this is same as the what here the, okay, if you want to get the clear of the efficiency here the t serial by t parallel dot p. Okay, this is the formula for the efficiency of the in order to get the efficiency in the parallel programming, we have the formula that the efficiency equals to t serial by t parallel with the multiplier of the p. Okay, number of p. If I have the 24 milliseconds, okay, if I have the t serial is the 24 milliseconds, 24 milliseconds, and also if you have the p equals to 8, number of processor, how many processor here, 8 only, and also t parallel is here the taking the time to convert the t serial programming to, okay, parallelism with the help of how many programs here, it will take the 4 milliseconds. Okay, 4 milliseconds. Then the efficiency, calculate the efficiency. Okay, calculate the efficiency, just to put the values here. Okay, whatever we have the values here, efficiency equals to t serial, efficiency is how much, t serial is how much, 24 seconds, and here the t parallel is how many numbers p is there, 8 is there, 8. Okay, just to put the parallels of t parallel is how much, 4. Okay, 4, just to cancel. Okay, it turns out 8 3 is ऐसा. Okay, this is to be what here the 3 by 4. Efficiency is here the 3 by 4. Okay, efficiency is the 3 by 4. So in order to get the efficiency and also spends the time here the average. Okay, if you want to get the average of this one, efficiency is here the e equals to 3 by 4. Okay, if I have the number of threads, number of cores, how many, 8 cores are there. If I have the cores here the 8 cores, and also we have the t serial equals 24 milliseconds, t parallel is the 4 milliseconds, with the having the what here the converting the t serial to the t parallelism with the help of how many cores, 8 cores. Okay, here I am taking the p as the 8. Okay, just they will ask for the examination, calculate the efficiency while giving the t serial to 24 milliseconds, and also p is the how many numbers, 8, and also t parallel is the 4 milliseconds. Okay, this is all about the efficiency. This is all about the efficiency. Hmm. Okay, this is the relationship between the speed up and the okay efficiency. Okay, relationship between the speed up and the efficiency. How many here? Just you look at here the is the period of okay. If I have the number of processors are one, then the speed will be low. Okay, if I have the more than two and also four, eight like this 16. If I increase the number of cores, then I should have to get the good speed and also have to get the good efficiency also. But here the if in the half, okay, if I divide that any process to be what here the divided into two halves. One to be how many threads are there? Around 32 threads are there. Okay, let it be consider the 32 threads. Okay, around 32 threads will be divided into two halves, 0 to 15 one hall, another 15 to 31 is the another group. Here the thread one, okay, whatever the group one will consist to be what here the half threads. Okay, we have the half. If I divide the process, okay, number of threads to be 32 into two halves, that is to be the speed, how much speed for the particular process, one process, and also efficiency. Okay, then the with the equal speed with the equal of the one process, I will be giving the 1.0. Here also efficiency is also 1.0 only. And also if I have the two processors, then I would get the speed is here the 1.9 because of the increase of the number of cores, so that my efficiency speed of the execution is also increases, and also my efficiency should have to increase here. Okay, increase. Okay, it is to be what here the decrease. Okay, decrease. Okay, and also if I have the 3.1, okay, then if I have the number of cores are 4, then the speed would be what here 3.1. Definitely efficiency should be zero point 0.7. Okay, and also 4.8 for the 8 cores, then the 0.60 is for the 8 one, and also 16 purpose I would have the 6.2 is the speed up, and the 0.39 is this one. Okay, okay, and also original form is also as the same as it is. Just to consider this one as the 1.0, 1.9, 3.6, 6.5, 10.8, 1.0, 1.95, 1.90, 1.81, 1.69. For double also we have the 1.0, 1.0, 1.9, 0.95, 3.5, 0.98, 1.4. Okay, if I go with the two halves, if I go with the original only complete process, only complete. If I go with the double, okay, double, okay, means what here the, if I go with the process, okay, process with the duplicate copy, then the speed and efficiency, there should I have to get the linearity between the speed and efficiency, here the half it to be considered, given the name with the half wave. of your size would be what here the is shown here, and also original form would be what here the hmm? Hmm. Okay. While referring this table only, while referring this table, I have to draw the some linearity here. Okay, how to draw it? Just to look at here. Like this, where the number of processors as the increases, then the linearity. Okay, so speed up also should have to increase, and also my efficiency also should have to increase. This is about the speed. I have to write the one more one more graph related to efficiency also. This is the while referring this table, I have to write the speed graph. Okay, I have to write with the similarly. I can write also write with the similar graph while referring the efficiency related to the number of processors. Number of process as the number of processes increases, then the speed of the execution of the particular threads will also increases. Okay, next is what Amda's laws. Amda's laws. Okay, Amda's laws ಏನು ಹೇಳ್ತದೆ ಅಂತಂದ್ರ in the 1960 ಟೈಮ್ ಆಯ್ತಾ. ಓಕೆ ಹಮ್ದಾಸ್ ಲಾಸ್ ಏನಿರ್ತದ ಅಂತಂದ್ರ ಕನ್ನಡದಾಗ ಹೇಳ್ಬಿಡ್ತೀವಿ ಕೇಳ್ರಿ. ಹಮ್ದಾಸ್ ಲಾಸ್ ಏನಿರ್ತದ ಇಟ್ ವಿಲ್ ಬಿ ಅಂಟಿಲ್ ದ ಕನ್ವರ್ಷನ್ ಆಫ್ ದ ಸೀರಿಯಲ್ ಪ್ರೋಗ್ರಾಮ್ ಟು ಪ್ಯಾರಲಲ್ ಪ್ರೋಗ್ರಾಮ್ ದ ಸ್ಪೀಡ್ ವಿಲ್ ಬಿ ಲಿಮಿಟೆಡ್ ವಿತ್ ದ ಎನಿ ನಂಬರ್ ಆಫ್ ಕೋರ್ಸ್. ಓಕೆ ಎನಿ ನಂಬರ್ ಆಫ್ ಕೋರ್ಸ್. ಹಮ್ದಾಸ್ ಲಾಸ್ ಏನ್ ಹೇಳ್ತಿದೆ ಅಂತಂದ್ರ it will be it says that only the unless the virtually all the serial program is to be parallelized, the parallel speed, okay, the possible speed up is going to be limited only regardless of the number of cores available. Okay, ನಾವು ಸೀರಿಯಲ್ ಪ್ರೋಗ್ರಾಮ್ ಇದ್ದು ಪ್ಯಾರಲಲ್ ಪ್ರೋಗ್ರಾಮ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಿದ್ರೆ ಅವಾಗ ಮಾತ್ರ ವರ್ಕ್ ಆಗುತ್ತೆ. ಏನು ಯಾವುದು ಅಮ್ದಾಸ್ ಲಾಸ್ ಏನ್ ಹೇಳ್ತದೆ ಅಂತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಸೇಸ್ ದಟ್ ಇಟ್ ಇಸ್ ಸೇಯಿಂಗ್ ದಟ್ in order to convert the serial program to parallel program, until and unless converting of the serial program to parallel program will not get the speed up of execution of the speed up regardless of how many number of cores. ಈಗ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಕೋರ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನು ಗೊತ್ತಾಗಲ್ಲ, ಯೂಸ್ ಇಲ್ಲ. ಬಟ್ ಥಿಂಗ್ ಇಸ್ ದಟ್ you have to convert the serial program to parallel program, then only will get the good speed up in the execution of the programming. Okay, this is all about the Amda's laws. Okay, I will teach you in detail about the Amda's laws because they might ask in the examination 10 marks also. Amda's law is very easy compared to the remaining laws will come the next coming classes.